Hello, dear friends. We had seen in the earlier video how to find out the initial basic feasible solution under northwest corner rule, least cost cell method, and WAN. Now, we will see in this video how to check whether the initial basic feasible solution that we have obtained is optimal or not. For this, we will take one question. Question number 13. Given below is a table taken from the solution process of transportation problem. So they have already solved it and they have got the solution. So this is the solution that they have obtained, and we have to check whether this solution is feasible. So to check whether the solution is feasible, you see the column total and the row total. So see here, it is 5,000, availability is 5,000. Here it is 4,500 plus 1,500. So it is 6,000. And here 7,000 plus 500 plus 1,500. The total is 9,000. So availability matches with whatever the allocation. Now check the row column wise. Column wise, here it is 7,000. This total is 5,500. Here it's 4,500 and here it's 3,000. So is the solution feasible? Yes, the solution is feasible because the demand and the availability is matched. Now coming to the second one, is this solution degenerate? To check whether the solution is degenerate or not, what you have to do is you see number of allocations. How many allocations have you made? This is 1, 2, 3, 4, 5, 6. There are 6 allocated cells. There are 6 allocated cells. 1, 1, 2, 3, 4, 5, 6. There are 6 allocated cells. And now you have to apply one formula, m plus n minus 1. What is m plus n minus 1? M plus m means the number of rows, n means the number of columns, so minus 1. M means number of rows, n means number of columns, minus 1. So m plus n minus 1 will be number of rows 3, number of columns 4, minus 1, we get 6. Because the number of allocated cells is equal to m plus n minus 1, that means this solution, there is no degeneracy. Is this solution degenerate? So the solution is, there is no degeneracy. Therefore, the table can be used for optimality test. So whatever you have obtained here, whatever the question that is given, we can check for optimality. So we can move to the second question. We can check whether the solution obtained is optimal or not. So how do we check whether the solution is optimal or not? So I'm going for optimality test under modified distribution method, popularly known as Modi's method. So first we will write table A. Table A is U plus V for allocated cells. U plus V for allocated cell. So for each row, we will write U1, U2, and U3. So the first row we'll say U1, second row we'll say U2, and third row we'll say U3. The first column we'll write V1, the second column we'll write V2, third column V3, and fourth column V4. Now, how do we find out the U plus V for allocated cells? So allocated cells means the cells where the some allocation is made. These are the allocated cells. What I'm coloring, these are the allocated cells, and the others are unallocated cells. Allocated cells I've colored now. Okay, so you have to find out the row or the column which has maximum number of allocations. The row or the column which has maximum number of allocation. In this particular first row, there's only one allocation. Second row, there are two allocations. Third row, you have three allocations. So I am taking the third row as the base. So you have to write here base, and the base value, you always take it as 0. I'll repeat again. The first row, there's only one allocation. The second row, there are two allocations. Third row, there are three allocations. The one which has the maximum allocation, that you take it as the base. So I've taken this as the base, and the base value you take it as 0. Now you ask yourself 0 plus what will give you this allocated cell, that is 8. 0 plus what will give you 8? It is 8. 0 plus what will give you 10? It is 10. Now 0 plus what will give you 14? It is 14. So the V values you have calculated, V1, V2 and V4 we calculated by using U3 is equal to 0. Similarly, now this is 14. 14 plus what will give you 10? Because here you have 10. 14 plus what will give you 10? 14 plus what will give you 10? It is minus 4. 14 minus 4 is 10. Next one, minus 4 plus what will give you 6? Minus 4 plus what will give you 6? It is 10. So 10 minus 4 will give you 6. So we calculated what is V1, V2, V3, V4. The last one we have to calculate what is U1. Now since this is 10, 10 plus what will give you 8? It is minus 2. So in this table, we have already calculated the U values and the V values. I hope you have understood. Now we have to move to table 2. Table 2 is U plus V for unallocated cells. So we have to see the unallocated cells. Unallocated cells means what? The cell where you have not made any allocations. You have not made any allocations. So allocated cells, we will strike out. Thus, we will strike out the allocated cells because allocated cells are not required for us. Allocated cells we don't need. So I have copied the same table and I have not taken these allocated cells. So the one which are colored, I am not taking these into consideration in the second table. This is table 2. U plus V for unallocated cells. So wherever there are allocations, those cells you can strike it off because we don't need them. In this table, we will not be using these cells. So I will strike it out. Now what I am going to do is, for the unallocated cells. Unallocated cells means cells where you have not allocated any units. They are unallocated cells. So in other words, the blank cells here. Okay. So for these cells, you have to find out what is the U plus V value. So that means minus 2 plus 8, you know, it is 6. And minus 2 plus 10, you know, it is 8. Minus 2 plus 14, you know, it's 12. Minus 4 plus 8 is 4. Minus 4 plus 10 is 6. And 0 plus 10 is 10. So I have calculated what is the values for unallocated cells. In other words, U plus V values for unallocated cells I have computed. Now the next step is table 3. This is the last table. In the last table, what should you do? You must find out the table 1 plus minus table 2 values for the unallocated cells. So for the unallocated cells, you will be finding table 1 minus table 2 values. This is called the net evaluation table. So table 1, what is the value? Unallocated cell, it is 10. And table 2, what is the unallocated cell? 6. So 10 minus 6 is 4. So you calculate similarly for the other cells, unallocated cells, and see if you have any negative values. Now, in this particular table, you have a negative value. Now, what does this negative value indicate? So the negative value indicates that if you make some allocation in this particular cell, that means wherever there's minus, to this particular cell, if you make some allocation, you could minimize the cost. You can bring down the cost further. That is what this particular table tells you, that is net evaluation table, NET. So table 3 will tell you whether you can reduce the cost further. So this option, whatever the solution that is given in the question, whatever the allocation, this allocation is not optimal. It is not the optimal solution because you have a negative value here. So if at all you make any allocation to this particular cell, then what happens? Your cost can be reduced further. So we will write here, is there a negative element? As there is a negative element, it is not optimal. So the solution, what is given in the question, is not optimal. So now what we have to do, we have to find out the optimal allocation. Now, when you want to make the optimal allocation, very important is, so remember, if you make some allocation here, which cell? This one, third one. If you make some allocation here, if you allocate something here, then what happens? You can reduce the cost further. If you make some allocation here in this particular cell, if you make some allocation, you can reduce the cost further. That's what we understood by doing the Modi's method for testing the optimality. So what we will do, if you want to make some allocation, so what should we do? We will follow the looping method. So when you're following the looping method, please remember the loops. Normally, the loops that we will be used will be, it could be a square, it could be a rectangle, okay, it could be a rectangle shape, it could be the whatever the looping, it has to be even-sided closed figures, even-sided closed figure. So you cannot have odd-sided figures. Do you understand? So here 1, 2, 3, 4, 5, 6. So six-sided figure, or the looping could be in this particular fashion. So normally these are the loops. So it could be a square, it could be a rectangle, it could be a hexagon in this particular form. Okay, so 1, 2, 3, 4, 5, 6. It could be in this form also. Now, when you are for making the loops, remember, so you have to make some allocation to this particular cell. So the looping will start from here. So here the looping start. This is the origin, and all the other corners should be allocated cells. All the other corners. Supposing you are making an allocation, you make a figure like a square or a rectangle or a hexagon. But remember, all the corner points has to be allocated cells. They have to be allocated cells. So here, if you're making allocation, you remember you can draw only horizontal line and the vertical line, no diagonals. So this is one line I've drawn. So this is a allocated cell. From here, I'll go to the next allocated cell. So this is the allocated cell. From here, I go to the next allocated cell, that's here. From here, I go to the allocated cell. Again, from here, I'll go to the allocated cell. And then I will finally reach the unallocated cell. So remember, this is the unallocated. From unallocated, you go to all the other points should be allocated cells, and it should be even-sided closed figures. Okay, so now what you have to do, what you have to check, is here you have to make some allocation, because you have to allocate some value here, some units here. So this will be plus. If this is plus, the next corner point will be minus. If this is minus, this should be plus. If this is plus, this will be minus. If this is minus, this will be plus. And if this is plus, this will be minus. So plus, minus, plus, minus, plus, minus, plus. So this will be the order. Now, at the negative corners of the cell, see here, this is minus, this is minus, this is minus. There are three minus corners. Now you have to check at these corners, which is the lowest minus, at the minus cells, where what is the lowest value? So here it is 1500, here it's 4500, and it is here 5000. So what we have to do is the lowest of these three, 1500, 4500, and 5000. The least is 1500. So at the plus corner, you write 1500. So at plus, you put 1500. Here, you need to minus from 5000, you need to minus 500, 1500. Here it is plus, therefore plus 1500. Here it is minus, so minus 1500. And here it is plus 1500. And here minus 1500. So remember, where there is plus, you will add 1500. Where there is minus, you will subtract 1500. So that's what you do to all the corner cells. So what did you understand from this? So here at this corners, this cell, you will be allocating 1500. And here it will be 3500. It won't be 5000. It will become 5000 minus 1500 will be 3500. Here it will become 2000, and here it will be 0. No, that means this will become empty. You will not be allocating any value to this particular cell. Here it will become 3000, and this will become 4500. It will become 3000. So these are the new allocations. So again, we will copy this table. We have made the looping. So what did we understand? To this cell, we will be allocating 1500. We will be allocating 1500. Here it will become 3500, and here it will become 2000. This will become empty. There no allocation here. And here it will become 3000. And here it will become, what is the value? It is 3000. It'll become 3000. So these are the new allocation. Here it'll remain 7000. So we have made some allocation here. And so this is the revised allocation. And now again, we have to check whether the solution is optimal. So whatever we have got done now, whether this is optimal or not, we have to check. So the first step is table 1. So table 1, what do? We will have to calculate what is U plus V values for allocated cells. We know what are the allocated cells. Here allocation is 3500. Here the allocation is 1500, and here the allocation is 3000. Here the allocation is 3000. There's no allocation here. 12th one, here it is 7000, and here it is 2000. I think these are the allocation: 3500, 1500, 3000, 3000, and 7000, 2000, 7000, 2000. Yeah. So these are the allocations. So now what we have to do? We have to find out, calculate the U values and the V values. So what do we do to calculate the U values and the V values? U values and V values, how do we find? So you find out the row or a column which has maximum number of zeros. So omni allocation here, 1, 2, 3, 4, 5, 6. 6 allocation. So we've got 6 here. So what we will do is, here also 2, here also 2, here also 2. You can take any one as the base. I'll take the first one as the base. So I'll write here, this is base. 0 plus what will give you 8? It is 8. 0 plus what will give you 7 is 7. Only for the allocated cells. Remember, these two are allocated cells. These two are allocated cells, and these two are allocated cells. So 0 plus what will give you 8? 0 plus what will give you 7? I filled up this. Now 7 plus what will give you 6? It is -1. 7 minus 1 is 6. Now -1 plus what will give me 10? It is 11. -1 plus 11 will give you 10. Next one, this is 8. 8 plus what will give you 10 is 2. 2 plus what will give you 8 is 6. So we found out all the U values and V values for the allocated cells. So this is your first step. Now, what is the second step? Same way, you have to calculate U plus V values for unallocated cells. U plus V values for unallocated cells. So unallocated cells, therefore, I will cancel out all this. We don't need the allocated cells. So allocated cells, I will cancel this. These cells we are not computing because it's already computed in. We cancel out all these and we will compute only the unallocated cells. Unallocated cells. What is U plus V value? So 6 plus 0 is 6. 11 plus 0 is 11. 6 minus 1 is 5. 8 minus 1 is 7. 7 plus 2 is 9. And 11 plus 2 is 13. So I have computed U plus V values for unallocated cells. Now I have to find out net evaluation table. So what is net evaluation table? That is table A value minus table B values. So I'm going to copy it here. The same cells I'm going to copy. So whatever table I've got, I've copied it here. So now I have to compute what is table 1 value minus table 2 values for unallocated cells. So table 1 value, what is it? Table 1 value is 10 minus table 2 value is 6. So 10 minus 6 is 4. Similarly, find out for the other unallocated cells. So this is the net evaluation table. After you do this, you look for a cell. See whether you have any negative values. You don't have any negative values. That means the solution that you have obtained now is optimal. So you cannot reduce this cost further. So whatever you have got now, the new allocation, that is the optimal solution. Okay, and you don't have a zero in this particular table. There is no zero. If at all there is zero, that means you have alternate solution. So in this problem, you do not have any zero values. Therefore, the solution what you have obtained is unique. You do not have an alternate solution for this particular problem. So you can find out what is the minimum transportation cost now. Minimum transportation cost. Minimum transportation cost is equal to how many units you are uh, uh, expo transporting. In the first place, it is 8 into 3,500. So right here, 8 into 3,500. 8 into 3,500. That many units you are transporting. Then 7 into 1,500. And then 6 into 3,000 plus 10 into 3,000 plus 8 into 7,000 plus 10 into 2,000. So this will give you the minimum transportation cost. So this is your answer. This is your answer. So we will just see. They have said, is the solution feasible? Yes, the solution is feasible because availability and the demand is matched. Is this solution degenerate? There is no degeneracy because m plus n minus 1 is 6 and the allocated set is also 6. Therefore, there is no degeneracy. And is this solution optimal? Answer is no, it's not optimal because we had a negative value in table 3, NET table. Therefore, we revised it. We used the looping and we found out what is the optimal solution. And they are asking you, does this problem have alternate optimal solution? The answer is no, it does not have optimal alternate solution because there is no zero in the table 3, that is net evaluation table. I hope you have understood this. Thank you very much. Have a great day. God bless.